Do you think that if you chase a beam of light, it will slow down? Completely wrong. Absolutely wrong. Even if you chase it at 99.99% of the speed of light, it will still move away from you at 300,000 kilometers per second, not a single bit slower. This isn't science fiction. This is the most unforgiving law of the universe. Even more astonishing is that, in order to preserve this law, time can slow down, space can bend, and even your mass can increase without limit. The entire universe gives way to the speed of light. Why? Because the speed of light isn't just a speed, it's the universe's default setting, a rule written into reality itself. No matter or energy can rewrite this fundamental law. In 1905, a 26-year-old Albert Einstein was working at a patent office while pondering a strange question. What would I see if I could ride alongside a beam of light? This question tore open the deepest secret of the universe and shattered thousands of years of human intuition. To truly understand this counterintuitive logic, we must first break down a deeply rooted assumption that speeds can simply be added together. Let's begin with a simple thought experiment. Imagine you are standing by the roadside, watching a high-speed train rush past at 300 kilometers per hour. Now, someone on the train throws a baseball forward at 100 kilometers per hour. From your perspective, how fast is the ball moving? Simple 300 plus 100 equals 400 kilometers per hour. This is Galilean transformation, a principle that works perfectly in everyday life. Velocities can be added. If you run fast enough, even a bullet could appear motionless to you. That seems perfectly reasonable, right? But what if you replace the baseball with a beam of light? If the train turns on its headlights, the light travels at 300,000 kilometers per second relative to the train. Logically, you might expect that from your perspective, the speed of light should be the train's speed plus the light's own speed. Perfect reasoning. Yet this is exactly where physics hit an invisible wall in the late 19th century. At that time, scientists believed light was a wave. Just as water waves need water and sound waves need air, they assumed light must also travel through a medium. They called this mysterious substance the ether. In 1887, two physicists, Albert A. Michelson and Edward Morley, conducted a famous experiment to detect this ether. Their idea was simple. Since Earth moves rapidly through space, it should experience an ether wind, like the wind you feel when riding a motorcycle. Light traveling with or against this ether wind should have different speeds. That seemed perfectly reasonable. But when the results came out, everyone was stunned. No matter how they measured it, no matter which direction Earth moved, no matter the season, the speed of light remained exactly the same, 299,792,458 meters per second. Even if you run toward the light or away from it, the speed of light completely ignores your motion. At the time, this felt almost supernatural, like chasing a car that always keeps the same distance from you, no matter how you accelerate or brake. Physics itself seemed on the verge of collapse. While scientists were trying to fix the ether theory, Einstein took a radical step. "He overturned the entire table," he said. "There is no ether. The problem isn't light. The problem is our understanding of time and space." This is the core of special relativity. It's not that the speed of light changes to match time, but that time and space must change to keep the speed of light constant, even if that means time itself must slow down. To make this clearer, imagine a strange scenario. You are on a spaceship traveling at half the speed of light. There is a lamp above your head, and its light shines straight down to the floor. To you, the light travels in a straight line over a short distance. But to an observer on Earth, things look very different. While the light travels downward, your spaceship is moving forward, so the light appears to follow a diagonal path. According to geometry, that diagonal path is longer than the vertical one. Here's the key point. If the speed of light is constant, but the distance appears longer, then the time must also increase. That means, from the observer's perspective, time on your spaceship is slower. This is time dilation, not an illusion, but physical reality. If you move closer and closer to the speed of light, your time slows down more and more, approaching zero. For a photon, time doesn't exist at all. From the sun to Earth, we measure about 8 minutes, but from the photon's perspective, departure and arrival happen instantly. There's no past or future, only an eternal present. This is the first consequence of the constant speed of light. Time is no longer absolute, but it doesn't stop there. Space itself is also affected. At near light speeds, objects contract along the direction of motion. The Earth, for example, would appear flattened, almost like a disk. This is length contraction. Space sacrifices its rigidity to preserve the invariance of light speed. The entire universe behaves like a stage that constantly warps itself to protect one rule, the speed of light. So why is it the speed of light? Why is there a limit at all? If the speed of light were infinite, information could travel instantly, but that would destroy causality. You could see effects before causes, or even send information into the past, leading to paradoxes like the famous grandfather paradox. To prevent this, the universe imposes a maximum speed, the speed of light. It is not just a speed. It is the speed at which cause and effect propagate. It is the firewall of reality. Einstein's teacher, Hermann Minkowski, went even further. He proposed that space and time are not separate. They are two aspects of a single four-dimensional spacetime. In this spacetime, everything is always moving at the speed of light. Even when you are lying still, most of your motion is through time. When you move through space, some of that motion shifts away from time, which is why moving clocks run slower. If all your motion were in space, at the speed of light, your motion through time would drop to zero. Time would stop, but this is impossible for anything with mass. As you accelerate, your energy increases, and that energy turns into mass. As you approach the speed of light, your mass approaches infinity. To accelerate an infinite mass would require infinite energy, something the universe simply doesn't have. That's why the speed of light is an unreachable limit. It also reveals something deeper, the geometry of space-time itself. When you move, you are effectively rotating your position in space-time, a transformation known as the Lorentz transformation. In this rotation, space and time change, but the speed of light remains constant. This suggests something profound. The speed of light may not really be a speed at all, but a fundamental property of space-time, a conversion rate between space and time, 299,792,458 meters per second. What we perceive as the speed of light is simply how space-time projects itself into our reality. And at this point, a strange realization sets in. Humanity believes it can conquer everything. We've built probes that leave the solar system and observe galaxies billions of light years away. But in front of the speed of light, we are barely even prisoners. We are just code running inside a system with strict limits. The speed of light locks us into a tiny corner of the galaxy. Even the nearest stars would take tens of thousands of years to reach. It isolates civilizations across the universe into distant, unreachable islands. Perhaps that's why we haven't found aliens, not because they don't exist, but because the barrier of light speed is too vast. And yet, from another perspective, this limitation is also what protects us. It preserves causality. It ensures the past cannot be changed, and the present remains real. Without it, reality itself would collapse. The constancy of the speed of light is both the greatest constraint and the greatest protection. It is cold and unforgiving, yet it quietly safeguards every moment of our existence.